Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In last video we discussed this time delay circuit and I received many questions on that video. The one question that how we can calculate the charging time of this circuit. How we can calculate delay time. Delay time of this circuit depends on the value of this resistor and the value of this capacitor. We discussed how we can determine the minimum value of this resistance. That depends on the junction voltage, Zener voltage and the junction current, base to emitter junction current. That will guide us to find the resistor value. Then we connect a capacitor here and we increase the value of resistance to obtain our required time. Now we will see how we can consider the charging time of this capacitor. When we connect a resistor to a capacitor, I am connecting two resistors, 1 kilo ohm resistor and 10 kilo ohm potentiometer at maximum level. So it is 11 kilo ohm resistance and 1000 microfarad. What will the charging time? When we say capacitor charging in DC, it charges in 5 steps that are called charging time constant. If a capacitor 1000 microfarad, initially it is 0% charged and its remaining charging level is 100%. We can say it is fully discharged. When we apply power in first step, it will charge its 63.2%. And how much time it will require, that will depend on the value of this resistor and this capacitor. T is equal to R into C. In our case, we are using 11 kilo ohm resistance multiplied by 1000 microfarad, 10 raised to power minus 6. It is 11 second time. In 11 second time, it will complete its charging level up to 63.2%. And the remaining out of 100, that is 36.8%. In the next charging constant, in the next step, it will complete 63.2% of this value. That will become around 23.2576. Total amount of the capacitance will be covered 86.4% in these two steps. When we covered 86.4%, the remaining 13%, in this time constant, it will take 63.2% of this value. That will become around this one. After completion of this level, our capacitor will be charged at 95%. The remaining 4.9% of the total capacitance, that is 4.98% of the total value. 63.2% of this value will be covered in this charging step. You can see initially it is charging rapidly, but here it is charging very linearly. It will become 3.14% and total charging level at fourth time constant will 98.17%. And the remaining amount 1.8%, that is 63.2, and it will become this value. And after fifth charging time constant, 99.33% capacitor will be charged. It will be considered as a 100%. So total time constant 11 seconds for each step. For initial charging constant, it will take 11, here 11, we can see there is a big difference between each step, but it will take the same amount of time. 11 second, 11 second, 11 second. So total time will around 55 seconds. Let's check it. I am using 12.38 volt, and now we will see how much time it will take to obtain this 12.37 volts. Now I will turn on this charging circuit. We will see graph on the oscilloscope, and we will check the voltage, and we will monitor stopwatch. We can see at 11 seconds it is charged at this level. Now it is covering 25 seconds, 30 seconds. In 30 seconds it is reaching to 11.35, and still it is increasing. Now we can see we covered 55 seconds and it is showing 12 volts. It will depend on the physical value of this capacitor and physical value of the resistor. We are considering the written amount on the body. We can see at 70 seconds our multimeter stopped to increase voltage, and both levels are now equal, capacitor voltage and supply voltage. We will check it again. When it will reach at 11 seconds, we will see oscilloscope and multimeter. At 11 seconds it reached about 7.5 volt, and now at 22 seconds it reached around this value, 86% of the total voltage. Now it is increasing, and we can see with compared to this region, the initial starting time, it is now increasing slowly. Here it increased rapidly, but now it is charging very slowly. At 55 seconds it reached 12 volts. So we can say that is closer to 99.3%. So in this way we can calculate the total value of the capacitor charging time. Now 11 seconds are required to complete charging level at this point. If we are using 10 volt, for example, capacitor will charge 6.32 volt in 11 seconds. Then it will take up to this level, whatever the voltage value is here, we will take this percentage of that value. So we can calculate the exact charging voltage with compared to time. Now we will compare the charging time. 11 seconds for first time charging constant, then 11, 11, 11, 11. Total 55 seconds are required to charge the capacitor at maximum level. For that purpose we need the exact value of the capacitor, the exact value of the resistor. We will compare time, voltage and the graph. We will turn on at the same time. You can see at 11 seconds it reached about 7.5 volts, and here it is charging. (22 seconds). Now it is reaching at third time constant, 33 seconds. That is here. that is 95% of the total voltage are here. At 44 seconds, that is fourth time constant, 98% of total voltage will there. At 55 seconds, this is the total time constant, fifth time constant, and the 99% of the total voltage are there. In this way we can determine the total charging time of a capacitor. If you enjoyed this video, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.